Hello, my name is Titus, and this is the iscc Ethereum IPFS registry hack, a proof of concept for a decentralized media content registry. So, what is the problem with the current crypto hash-based content addressing? So the main problem is that from a human perspective, content is really something different than data, and cryptographic hashes identify data and not content. So for example, if you look at these two images, from a human perspective, they are the same content. But if you create a cryptographic hash for content addressing, then the hashes will be completely uncorrelated because the data that is underlying the two different image encodings is very different. So what the iscc solves, it will create the same content ID, or at least a part of the content ID will be the same, if the structural, visual, perceptive content is the same or similar. The idea of this hack is to implement a decentralized registration protocol. So we take a full iscc code, everybody can generate it for any kind of digital content, and then you can register it on any public blockchain. And what the protocol does, it indexes or watches, observes the different blockchains, and comes up with a short ID that resolves to the full iscc code, but it is owned by the person who registered the code, and it is globally unique and short. So what does the hack actually do? So a fair warning, this is not an end-user application, it is nerd stuff, command line stuff. And what we built is a proof of concept of the whole flow for a decentralized registration protocol. So here's a demonstration of the actual hack. We have many moving parts. So we have a local test environment Ethereum blockchain. We have an IPFS daemon running. And here we demonstrate the command line tool. So what can it do? We have basically four commands. One command is to deploy the contract to the Ethereum chain. Then we have the observer service that watches the contract for new iscc registrations. Then we have a command line tool, command for registering iscc codes and for resolving iscc codes. So let's first deploy the contract. irag deploy. Yes, and yes. So the contract has been created on the chain, and the local configuration has been updated to use that contract for registering iscc codes. Now, as the next thing that we need to be running is the observer service. So irag observe. So this basically is a service that watches the blockchain for registration events and then calculates the unique short iscc ID. So now we can register some digital content. So let's try with register. So this is the iscc code that has been generated. We say yes to registration, and the contract has been called, and the iscc has been registered. And this is probably the iscc short ID that has been generated. We don't know for sure because there can be race conditions. We need to ask the meta index to be sure. And we can try to resolve this new short ID. Resolve. We have that short ID. Yes, and it works. So the short ID resolves to on-chain data, the full iscc code, the wallet ID who registered it, and the content ID that points to the metadata of the registration, which is stored on IPFS. So this metadata was extracted with the iscc generator, encoded in CBOR, stored on IPFS, and is now resolved from the short ID. Thank you for your time, and thanks for this great hack event, which was really a lot of fun, and I learned an awesome amount of new stuff.